Okay, what do you know about the fundamental theorem of calculus? Basically, when I learned this, when back then when I learned this, I just feel like, why is it so straightforward? Like it doesn't give you any like real meaning. It's just showing you the relationship between the derivative and antiderivative. That's it. Okay. There are two parts, right? Did you learn this one on AB? Right?
Maybe.
Maybe you heard about it. Maybe you have seen it, but you're not going into detail, right? So there are two parts. So FTC part one. Part one is just saying. If
Can we mute guys?
it shows the relationship between derivative and integral. They just reverse. So they're just saying that. Very straightforward. Very straightforward. Do you remember if and then? All the theorem they only have two sides. If, then. If this happen, if it's satisfied, then you have this. Okay? Always think about you need this one to be happen, then this one you can apply without any proving. That's very very strong for that theorem. I mean very helpful. Then the derivative of f will be equal to f what? No, it's good. It's good. What do you think? If the integral, if the capital F is the integral, if you take in the derivative of the integral, what do you have? What is the square root of square? Okay. What is the? Let me say it again. What is the square of square root of 2?
Just add.
Imagine that. Imagine it. Square of square root of 2.
Just 2.
The 2, right? What is square root of 4?
FX.
2
Huh?
squared. Wait.
What is square root of 2 square? How about this? 2. Because they cancel out, right?
Yeah.
What I'm trying to say is they cancel out.
You're taking the derivative and integral.
Yeah, you take the derivative of the integral. What do?
You just
They're going to
cancel out.
cancel out. So that's the fundamental theorem part 1. That's it. That's why when I learned this, then what is the point? We know this. We know this, right? So it's going to be fx.
No, FX.
You take in, you cancel the integral. Then you're gonna have this. Okay? Yeah? That's the part 1. So the meaning is, what is the integral about? Integral is about? Yeah, but in the geometric things is you calculate the accumulated area, right? Integral is you made a Riemann sum, right?
Oh, that's true.
Integral is finding the area under the curve. You know that one, right? Your face is scary.
Like when, like.
The trap is
Okay, let's start with the
not the
derivative
trap.
first.
I mean the square is. No, yeah, the trap is.
Let me find a way to write it so you can understand it easier.
The right hand? Yeah. It was like the triangle. What should I do? The rectangles or the should add
Okay, integral is the area under the curve. So let's say we have fx is like this. Okay, I try to make sense for you so you understand it. Like this. Does it look familiar?
Oh yeah.
Right? Okay. Okay. Now, if you take the derivative of this whole thing, what do you think they're gonna do? What do you think we're gonna do? So, okay, they write down in. What do you think? Any guess? Any guess? Let's say I'm gonna take the derivative of this one as one point here. Then what do you get back from here? The position, the height. It to be more precise, the height of the function at that point. Okay, you're gonna get back the function fx. Okay, integral is the area under the function. You take the derivative, you get back the function. Okay, how about that? Maybe make more sense. Oh, okay. Phew. All right. Make sense?
Yeah.
Integral area under the curve, under the function. If you take the derivative, you get back the function. So in other words, you get back the height, right? This is the height, right? The height of the function. Okay, so that's the meaning. Because when you understand it, you're just gonna make it. You can memorize better. I try to use the language you understand. Okay, so Fs is accumulated area under a curve. So when we take in the derivative of Fx will give us back the function. The function Fx, that the curve, not the area under, but the curve, okay? But the curve. Or, i.e., the height of the function at that point. Okay, make sense? So that's the fundamental theorem part 1. That's literally what I say. If you have some area of the under the curve, you take the derivative, you get back the function. That's fundamental theorem part 1. Okay, easy? You understand now? All right. Okay, let's part 2. Fundamental theorem part 2. Oh, we didn't record it? Oh yeah, we did. How do you say height in height and this? Are they the same? How do you say it?
Height.
This one, height, and this one.
Night.
That's not a word.
Is that night?
Oh, height. Oh, height. Oh, it's height. Right there.
Oh, like high?
High, and how about this?
Like coffee?
Height.
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 No, height.
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 Yeah.
It's still I, but
Yeah.
it's got a T. Height, and this one is just height.
Yeah.
Ah, okay. It sounds the same to me. Okay. All right. Fundamental theorem part 2.
Oh, it's long.
Mr. Parker,
Yes.
could you make your pen in Galaxy?
Yes. That's it. All right. Can you read my handwriting now?
No, yeah, Mr. Parker, could you change the ink to Galaxy?
Chen.
The color. Like the color. That can go to
Oh,
the color.
oh, okay, sure. All right. Sure. This one?
Yeah, no, that's
This one?
Galaxy, yes. Galaxy?
Galaxy. So you just did before. Oh, you're like master of this. So part 2 is literally the same. You evaluating. Okay, this is just evaluating. Can you see it though?
Yes.
Yes.
I think green.
It's like
I should say mine
uniform.
green.
You choose it then.
Evaluating definite integral.
It's so cute.
Using antiderivative.
No, it's 2016.
Okay, so what do they say? I'm gonna change color to be consistent with this. Okay, the note when we're gonna use Galaxy for the note. Okay, if 2 part, right? If f is any, remember any antiderivative of f. So meaning ff equal to fx. Right, similar to part 1. Okay, similar to part 1. Same condition. Then you're gonna have it's so straightforward. That's why when I learned this, I'm like, what the point? It just makes sense, right? Because we only learned this. It just saying, again, part 2 is just evaluating. if you have the integral of the function from A to B, that means you're just finding the height from B minus the height from A. That's it. So that's what they're saying.
Why do we need to learn this?
It just we learn how to do it first, and then we learn about the theorem. That's why we should learn about the theorem first, and then we learn how to do it first. Yes, like what I meant is you should learn this one first, and then you know how to evaluate the integral by doing this. But because you all learned this in AB, right? So you already knew how to do this one already. That's why when you look at this one, you're like, oh, this one we know this. Yeah. So the meaning. Okay, let's also do the meaning. The meaning is the total. What is the meaning? When you take in the derivative, what do you have?
Velocity or position.
Yeah, but in this context, what do you think is meaning? From part A, you take in the derivative, that means you're gonna using you get the function at that point or the height, right? How about this? Remember, f is the derivative, okay? F is the derivative. So if you take in the integral of, if you want to find the total area under the curve from A to B, it will be the derivative of end point minus the derivative of starting point. That's what they're saying, okay? That's what the meaning of fundamental theorem part 2. Let me say it again. Yeah, I love the moment like still aha moment. I have that too when I learned math. Oh, yeah, aha moment. That's when you understand stuff. So I say it again. The integral means the accumulated area. The accumulated area of under the curve from A to B, for example, from A to B, will be equal to the derivative of the end point, the B, minus the derivative of the starting point, the A. Okay? All right. Let's write down.
Oh, why am I thinking? No.
Value of antiderivative. Value of antiderivative at the end point minus value of antiderivative of starting point. Okay? Antiderivative, not derivative. I think I said earlier. Okay, so let's do some example. We can do galaxy for example.
Why is it green?
Yeah, it's a different color. Let's keep changing it.
Why are you obsessed with drawing that?
Let me give some piecewise function. Alright, this is the fx. Approximate. You still remember the Riemann sum? Yeah?
I remember the trapezoid one because it's more vague.
The portion?
No, the one not as square, but it has like also the
Triangle.
so a trapezoid
Oh, trapezoid. What did you learn about it?
that it's more accurate.
Ah, the medium, the middle.
Because we don't want to overdo it.
Yeah, so left and right and middle. Maybe you don't want middle. Yeah. Okay, so you're good about this. Yeah. Okay, how do we approximate it using the left Riemann sum?
I don't know my left and right.
How do we do it? Did anyone still remember the left Riemann
The
sum?
left one is from this side. So it's.
Yeah. So what should we do first? Huh? You're gonna cut it in 4 because it's asking you to start it at 0 and end it at 4. Okay? At least it's better to just, for the sake of practicing, we can just cut it in 4. Okay? Very good. So 1, 2, 3, 4. And then for the left, what you gonna do?
You make a triangle. So you
Triangle?
make
But a
I
line.
mean,
But a line. But where's the line come from?
From the
Come
left
from
side.
here?
No.
From here?
Yeah, the x-axis.
That's right.
Yeah.
You go from the left. From here, right? What else? And then you keep going with the. You keep going with the left point. Okay, all the left point, all the left point, all left point. Yeah. This, do you agree? And what does the last one look like?
It's gonna be big.
It's going to be over like this.
Yeah.
Then I use different colors so you can see what happens. So the red one here, red one here, red one here. So that is the left Riemann sum. Okay. Does it ring any bell? Still remember this? Okay, good. So how do you find this? 0 to 4. Let me give you
Mister,
mhm.
don't we do base times height and then we just add them all up?
Base times height.
You find the area of the rectangles.
The last part? Oh,
Or,
no.
because
the
Mr. taught
rectangles,
us
that's
to
just
do
cut off.
the, like for,
So then it's
what
either
is
just
that?
an overestimate or an underestimate.
A trapezoid? Wait, no, what is it called?
Maybe make the yeah.
Jasmine has a question.
Yeah, question. Yeah, question. Yes, any question? Yes.
You know how there's like left and right? What's
Uh-huh.
the one with the center?
It's the middle. It's the name. Unless unless you're using another name.
Give me now, I'm trying Mr. Sushuk, Riemann sum trapezoid.
Okay. Yeah, usually we just call left and right and middle. But that's it. Trapezoid.
Yeah, we get the trapezoid.
So you learn trapezoid as well.
Yeah.
Okay.
Yeah, we actually learned.
But I can't really do that one. Because I'm not good at doing
Trapezoid like you very along the curve. Okay, let's just find the area. The area from 0 to 1 is how many? I put a number for you already. So 1, 2, 3, 4, 5,
I've
6.
been working more.
From 0 to 1, what is the area for this?
She was like,
You have 2. Yeah, 1. Yeah, I know. It doesn't look. 1, 2, 3. All right. Let me do it again.
And it's like half.
No. Same picture, but I'm gonna make it. I'm gonna make it easier for you to see. Okay, like this. 1, 2, 3, 4, 5, 6. Okay, I'm gonna do this. Same picture anyway.
No, no.
Oh, really? Oh, fuck. Oh, I can't extend my arms.
what happened?
That's the function. I just make it clearer. And then you're gonna do, this is the left.
So 8 plus. Oh, that's not 8.
No, but what?
I mean, yeah, 8 plus 2 plus 6, 7 plus.
Okay, 2, right? How many area for the first box? From 0 to 1, how many? 2. Second box?
8.
8.
8.
Yeah, it's 4 times 2.
Oh. What's the,
Eight?
What's the number that we're using?
Why 4 times 2?
Oh, it's 4.
4 times 1.
Oh, wait, 4.
From 1 to 2. From 1 to 2.
Yeah,
This area, this area, this area,
because I saw 2, mister.
this area.
But I'm 9.
Okay. I agree.
Thank you.
Let's see. So then equal to 16. Notice, I just put, what is it called? Approximate, okay? Because this is not really the area under the curve. We just do the left Riemann sum, okay? How about the right Riemann sum?
When you start from the right side.
Wow. I wish I was the smartest.
Can you do the right by yourself?
Did you get on this?
Yeah, do the right by yourself.
No, you're.
What's that? What's it?
Is it? Is all of you submit the picture? Yeah. Oh shit.
You want me to do a picture?
Today is the last day.
Really sure for what?
I'm gonna just
Yeah,
submit a
we
picture.
submitted. I submitted it already, mister. At like midnight? Oh.
Sure, midnight. Midnight. That's it. Okay, midnight.
Midnight.
Mister, these are some
You're the little kid.
I already turned it in. The day he sent it.
Yeah. See the first one.
Release.
How do you write it right? Let's do it. I'm gonna go around and see.
There is any on the Scantron.
But
I'll
I mean,
just
it's not a
circle either
question.
one.
There's no question for that. Okay, what did you get for the right? So the right, you're gonna start from here, right? You're gonna use different number, different color. And then, what did you get? Raise your hand if you got the right Riemann sum already. Raise your hand. 1, 2, 3, 4, 5.
Wait, what's up? 6, 7. Wait, 6, 7.
Oh, you got 5. 6. And finally 7. Okay.
Oh, no, we have to.
That is very simple.
Wait,
Yeah.
wait.
What did you get? Okay, any for those who just raise your hand, what did you get? Isabel, what did you get? 14. If you got 14, it's correct. No? Yeah? Okay. Alright, good. It's gonna be the picture gonna be like this, right? Oh, what do you have for the 4? It's 0. So like this. Okay, so you only literally just calculate this, and then calculate this. So you're gonna have 4 plus 4 plus 6, and that is 14. Okay? Okay, midpoint. Middle Riemann sum. Midpoint.
Oh.
I don't want to drive this.
No, it's getting bigger.
Number 4.
Like his dad.
Not? Yeah. This one. See? This one. And this one is where I play music. I use this one. I use this one for my gig as well.
I'm not the hero you're saying he is, but I'm the hero you're saying he is.
calculate the midpoint. Let's do the midpoint. No, from 0 to 1. What is the middle? 0.5. You start from 0.5 and you draw the box right there. That's the midpoint. If you kind of confused how to do this. So like this. From 0 to 1, I know the midpoint is 0.5, right? So I'm gonna go up, and when I hit the graph, I'm gonna start drawing the box right there. Okay? And then same thing, I'm gonna start with the 1.5. I'm gonna keep going until I hit the function. I'll start drawing the rectangle right there. Okay? That's how you do midpoint. And then 2.5, right? 2.5. I'm gonna go up and hit the function. I stop right there. I'm gonna draw a rectangle. And that is 5. And the last one, 3.5. That's why they call midpoint. 3.5 at 1, 2, 3, right? 3. It's still 3. So they're all 3. So what do you have for this? 15. Because the first one you have is 3, right? 3 plus what?
4.
3 plus 4 plus 5 plus 3. And that's give you 15. How many of you got 15? Eventually. Good. Good. Very good. Huh?
Like, it isn't difficult, it's just too much graph.
It's too much graph.
I don't get these things out when I ask you.
I got a question for you.
Don't say
Why you want to make it? Yeah, no, you're on. That's too old already.
Okay.
You know what? You should be a vegetable.
No, my favorite part is when like when he's
Wait, what's the sound effect?
All of my
Yeah.
Listen up.
that's my favorite part.
There's a yogurt salad.
Oh.
No, you can't. When you told us, he was like, you can't eat the flour. I mean, technically you can. You lied to us.
Right now.
No, that's how they never do it.
That's fine.
I know.
6 and 7.
Yeah, is he actually going? Okay, good.
If you try to cut them into
Jesus
Christ.
Oh, you don't like Sarah's confession.
It sounds good.
It's so majestic.
That's why I like the style. It's a
Hashtag green.
Losing streak.
Whoa.
the Chabozoe.
No.
Too able part. That's
Do you remember how to do a
Oh,
Chabozoe?
my God.
I need a white one. Are you using it right now?
Wait, no.
You can draw
No, bro, no, I need it to go switch.
Your dad. Sorry, wasn't
Wait,
were you
wait,
ready?
No. That's the
That's so wrong.
I know.
Oh dear, Dad, tell me what you would have done.
Oh, yeah.
Too bad. I just know right now. It's like, let me stop.
So huge. Fuck.
Let's actually.
That song.
There was shit on it.
Yes. And I used to think that.
No one's getting paid this room. No one's getting
Yeah,
paid.
all of them.
It was like.
See who gets the
that one
most
time we
accurate
went.
number.
It's where he's blocking.
Should we do a combination of all of them? I think that's the most accurate number.
Yeah.
What do you mean? Like take the average?
No, because one of them is square, and then there's
Oh, yeah,
two
you
sides and one
But
is
isn't that to
So
me?
you can do it.
Yeah. That's what I'm gonna do.
Trapezoid.
Or did I do?
Remember the trapezoid?
If you just add to evaluate, how do you evaluate? You gotta find a real. You gotta do trapezoid and part E then.
Oh, when you find all of the area?
The area. You gotta find the real area. Good job.
Oh, I still don't do the actual math. And then it's like geometry.
Not geometry.
I can't do geometry.
How do you find the area of this?
Is this
You can. How do you find the area? Okay, area of this one easy, right? Area of this one easy. How about area of this one? Also easy because a triangle. How do you find the area of this?
trapezoid?
How do you find the area of trapezoid?
Base 1 plus base 2 over, times height over 2.
Yeah. Try it.
Try it?
Can you do the trapezoid and then I do the
Just do
square?
triangle and then a rectangle or triangle. That one would just be a triangle and a square. Unlike the
You want me to write down?
I can't do this. I can't do the trapezoid.
It goes down the same.
Trapezoid area.
Sorry.
He did that. When I like.
Why do you lie?
Interlinked moment.
Shut
Wait,
your
you
dumb
know,
ass up.
I low-key felt like, the two aliens when they're
Locked in aliens.
yeah. Why was that low-key us for a moment?
Okay, let's not sing for 30 seconds.
What is derivative represent?
No, but like.
Derivative is the velocity, the rate of change, right?
Yes.
So rate of change of velocity. So if you take the integral of the rate of change, it's like I asked you before, what is the square root of 2 square? What you're gonna do with the square root and square? You're gonna cancel out. So same thing here, the velocity or the rate of change and the integral they cancel out. So the answer is the position. Okay, that's our position. But what is this then? They will give you the position. But by fundamental theorem, what is this equal to? X?
XT.
X? What you gonna do with the integral and the derivative?
You're gonna cancel.
You cancel, right? So what do you have left? Fundamental theorem, the part 2. Fundamental theorem part 2. What is this? This actually equal to this, right? So integral of this, the derivative and the integral, they cancel out. That's why you have this. So okay, let add them here so you know what's going on. So I can rewrite this one like this, right? Because this equal. If this happen. If this satisfy, that means the integral of function f equal to the integral of capital F prime. What happened when the integral and derivative? They cancel out. So they just equal to f of ending point minus f of starting point. So yeah, so that's why you're gonna apply to this. Apply the fundamental theorem part 2. What is this equal to? X 8 minus x 0. That's it. Okay, it's it. Now you have in-depth understanding of fundamental theorem. So okay, the real answer, give one sentence answer is. So this one represent the change in position, in feet,
Oh, sorry.
from t equal to 0 to t equal to 8 seconds. Okay, you have second, you have feet here. Do you remember how to write the integral in the sum notation? Remember? Riemann sum? Okay. Integral from, let's say, A to B. Let's just do fx, okay? Riemann sum, that means you're going to add on the area, right? What is the notation for the sum? The? Right? Okay. But because you're taking the limit. Have you seen this? Yeah. From where to where? Let's say I'm gonna do f of xi.
Oh my god.
Because
Funny. My bad. Jesus.
okay. Let's say this is x1, x2, x3, xn. Okay, that's what we're gonna do to find the integral. So,
So if I give you orange,
how do you find the area of this? Base sum height, length sum width, right? The length is going to be the function f of xi. I can be anywhere from 1. You understand? Okay, let me write the whole. Because I want you to come up with that by ourselves so you can remember. Where I going from? I go from 1 to n, right? So I go from 1 to n. Where n going to though? The limit.
Which we don't want to. So
N go to
infinity.
infinity. Good. Okay? Because we're taking a limit. We're taking a limit. Okay? Now, how do you find the area of the rectangle? Base, sum height, or length and width, right? For this one, you're gonna multiply this. Let's do the left one. So you're gonna multiply this. What is this? This is the f of x1. That's why you're blocking y, blocking I equal to 1 here. You're gonna have f of x1. Multiply by what? Multiply by this. What is this? They're all gonna be the same. Remember that. They're all gonna be the same. Okay? What is this? Not 1. That we don't know. But how do we write it? The difference between x2 minus x1 or x3 minus x2, they're all the same. So how do you write the difference?
Yeah.
Delta x. You seen it before?
The rate.
No? Yeah, delta x is the difference. They're using this one for a difference. They call delta. Okay? So, if you want to write explicitly, what does it mean? This means you're gonna do f of x1 limit of f of x1 times delta x plus f of x2 times delta x plus everything f of xn times delta x. How do you find the delta x though? What is the delta x? If you know you have from x1 to xn, and you know that you're gonna divide this amount of time to get each of them, they're all equal. How do you find each of them? Xn, where delta x equal to xn minus x1 divided by how many portions? N of them, right? Divided by n. Have you seen this?
So the infinity.
That's the Riemann sum. That's the Riemann sum.
X
But in general,
minus x1.
okay,
It makes sense.
let me give you a sample. So for example, we're gonna do from 1 to 8, okay? Some function. We're gonna do left. So 1, 2, 3. So delta x here is 8 minus 1 divided by n minus 1. So n minus 1
Divided by 8. No?
divided by 8.
No, it's not. It's not.
Divided by n minus 1. Because it depends on where you start. You start from x1, if you start from x0, that's going to be different.
So
How do we consider one?
you want to confirm by
And the number, because this one is going to be 1, 1, 2, 3, 4, 5, 6, 7, n minus 1. Because when you cut in by 8, you only have 7 of them.
Wouldn't it be to start at 0?
So, okay, to be more precise, you can just do this. b minus a divided by a.
Huh?
once you.
Oh. You can't do it. Go fucking finish your episode. Go sit.
You don't need to like really know it about this. Get it in general. So at least you know what's going on, but you don't need to like really understand what's going on here.
You missed the whole explanation.
So what I want you to know is this equals to this. That's what I want.
Mister, that's just the theory to Riemann sum.
That's just it's just the integral, but by Riemann sum formula. You take in basically you're gonna take in the sum of each area. How do you find the area of rectangle? Length sum width. This is the length. This is the height, right? That's the height. Depend on you do right or left. And then this one is just the width. That's what it's saying. Okay, you're gonna take the sum of that from the beginning to the end. And you take the limits because it depends on what you're gonna do. You're gonna do left or right or middle one. So that's why you're using limit. That's it. I just want you to get used to what's happening.
What? When is that from?
So similar to this question number 2.
Oh.
Let me ask you. You got
When he's crying in the car. Cause he's gay.
What?
And season 4 when he confesses to Mike, and then he's like, "Well, that's cool," and then he's just like, "I'm not gonna lie, I really fucking hated Will like the last episode." That was really fucking.
I just thought he was like.
No, he's the main character.
Yeah, bro. But it's Will's story, bro. Fuck you trying to kill the main character.
I feel like he might.
the momminess. It's
No.
I haven't seen anything.
Oh, fuck. I already told her why. Like,
Why?
oh, never mind.
I didn't hear anything.
Yeah.
I haven't seen season 5. I'm on episode 1.
You're fucking behind. Bro, I watched that shit on like the second.
I was doing my reading college.
Fuck college,
Yeah, I
bro.
was
The
gonna-
second, bro.
I was gonna, once I say it right now, I'm gonna leave
No,
my
I know
phone.
what you're going on.
Bro,
I
this-
had to put that.
Bro, I DoorDash 3 pizzas and I binge watched that shit. I ate like 2.5. I saved like 4 slices the other day.
Oh, so thoughtful, bro.
Bro, cool.
I'm getting tired of him.
I just don't like thinking about these things. Because when I don't think about it, like it passes by quickly. And then by the time it's back, it's just like, oh, it drops tomorrow. And I'm like, nah. Christmas.
Christmas in the year. No, but Alistair.
Christmas drops 3 episodes, and New Year's drops the finale.
What about,
No. Because the finale drops on January 1st of 2026.
Exactly.
Yeah, exactly. I think we'll drop at like At like, yeah, exactly 12.
Bro.
Fuck no, bro.
We're putting that on the big screen.
Bro, my mom always like come up to me. She's like, "Oh, we gotta pay for the new year." Bro, this might be the first year I gotta be like, "Hold on, mom, like, we got let's wait 2.5 hours."
Bro.
2.5 hours?
Yes,
Each episode is like right now an hour, right?
Yeah.
an hour 25.
Okay, let's do this one fast. Let's do this one fast.
Only episode 2 is like 50.
Fast.
Is it real quick?
So the reason that I introduced you this because I want you to look at the unit. Okay. Okay. Do you know why they're using the dx? Have you seen dx over a place, right? Do you know what the dx stand for?
No.
Not really.
Not derivative. Compare these two.
Oh, the rate. The rate.
Distance. Wait.
This is this. This is this. The difference, the delta. dx is the delta x. That's what it means. Okay. So okay, let's do it quick for this one. I think this one is easy. What is CW, C prime W?
Just by itself.
What is the unit? What is the unit?
Capital C.
Calorie
Calories per pound.
per pound, right? Calorie per pound, right? And then if you do, what is the D of DW? What is the DW? What is the unit for the DW? Pound. Yeah. The difference of pound, right? D is the delta, the difference. D is difference. So it's a pound. So what you're gonna do with a pound?
Cancel out.
You cancel out a pound. So what is the derivative of this? The unit for this is going to be
Calories.
just calorie, right? So this is 120 from 180, and by FTC part 2, what is this whole thing equal to?
Capitalize C.
Yeah, the C of what?
C of 180.
The integral and derivative, they cancel out. So C of 180 minus C of 120. And what does it mean? So how do you interpret that? This one to get you understand really happening to integral, not just like do the formula, second integral. You need to know what's really happening. So now you know D is the difference, okay, the delta. So and then if you want to know what is the unit, you can do like this. The rate of change, that means you have calorie per pound. Multiply by the difference of pound, it still have pound. Pound cancel out. The unit for this one will be calorie. In fact, if you're using the FTC part 2, you're gonna have the calorie of the person who is 180 pound minus the calorie of the person who is 120 pound. So the difference, it's still talking about difference. So let's write. So meaning is how much more a 180 pound person
Wait.
needs to eat than a 120 pound person. Each day.
Oh, yeah, how many calories? Wait.
Each day in calories. Okay, that's it.
And that gives you C60. And then you need to find out what that is.
Oh, I can send to you too. The training, you want to?
What?
You want to send too? So that you don't need to download it. Do you need to know? Oh, you have it. Okay, never mind. All right. Oh, that's good, huh? If you want, you can just bring the laptop and I get the AirDrop to you. Okay.
Where are phones?
Just in a minute.
Bro's airing out the
Imagine the reasonable walk-in. Everybody using phone.
Everybody, I mean, mine's
I
like
can
the.
fold it under zero pressure, bro. Why you send it to your laptop? Or my phone. Your shit was there the whole time.
Mighty no, but
Oh wait,
I
oh,
did
Vincent's
Spider.
getting, wait, Vincent's getting no sleep.
Oh yeah.
Dosage?
Yeah.
Dosage calculus?
I thought were those highlights. You know those snippets, those highlights? Oh, no. Oh, I'm fine. That sensor highlights?
These are
Oh, I
technically
put right here.
But it's not. I'm good. I don't want your diet.
No, I'm gonna come home for that. Let's say sometime I did wrong
I was
too.
dying.
I did too fast.
No.
Maybe we stack too. So 5B, continue part 2. Recall. Last time, right? Last time. That's 5B, right? Because we see on 5B. If let's see how we phrase it. If f capital is the integral, then derivative is a function. Yeah.
Wait, mister, can you get a 7-Eleven cookies?
Hmm?
No, McDonald's cookies. Oh, have you seen the Pazuki McDonald's?
Yeah?
Yeah.
Oh, does she have the Grinch socks?
Yo, that's actually.
And we're gonna go fucking buy them.
Wait, which one
today.
do you have?
Just
Just 'cause of that.
I gotta go buy them. Baby.
I got yellow.
I'm only the red one. I'm trying not the red. That's actually tough.
I'm gonna bring my yellow one.
Green is golden. Green is Frenchie.
How do you come through? I can't get my orange, so I gotta go 6
Oh, I know.
6
R.I.P.
So this is what we did yesterday, right? If the f capital is integral, then the derivative is going to be cancel the integral to give you back the function fx. Okay. So the other way to write the derivative is this, right? The same thing. Same thing. Yesterday we didn't have this, but I just explained. Another way to write is the derivative of this is d over dx of the whole thing. Okay. Same thing. Same thing. So last time, that's from last time. Have you ever wondered what happened to the a? Because this one is just fx. It's just fx. So what happened to the a? So let's do a sample and you will see how it's a practical application of the FTC here. So continue a sample.
Mister, what does FTC stand for?
I mean, no, that's different.
We have been this is second lesson and you ask what is sample.
Does it not mean flight teacher standard?
It's fun to cook.
Fun to cook.
Fun to be cooked. You cook. Okay, what is this equal then? Is that by FTC immediately? D over dx, that means you're taking the derivative.
Yeah.
Derivative of integral. What happened?
Cancels up.
By FTC part 1, they're gonna cancel out. But what is it equal then? It equals exactly the function inside, right? Which is, so what is the answer? 2t?
Yeah.
What? Look at the FTC. ft dt. Then the derivative become fx. Where's the x? X is actually
So
Yeah, so 2.
the upper limit. Now look at the detail. Zoom in. Zoom in. If you look outside, it's just derivative of the integral. But if you zoom in, the function ft dt is changing by the function of the upper limit. What did the a stand for? I mean, what do you think is a? Usually when they write a, that means a is a any constant. Okay, a is any constant. Whatever number is, but it doesn't matter. You just need to replace the top, the upper limit, into the function to become fx. So apply that one FTC part 1 into here. What is it equal to? 2x, that's it. Yeah. And you feel like, oh, why we need FTC? This FTC actually save you a lot of time. Let's say if you don't know the FTC, okay? You need to take integral first. Okay, actually let's do it. The more we do it, the more we understand it. Let's don't do, okay, let's don't do the FTC, okay? By FTC part 1, actually part 1. Now, long way. Let's say if we don't know the FTC, then we're gonna do what? You're gonna take the derivative, integral first, right? What is integral up to t dt? What is integral up to t? 2 2t square over 2, right? Everything from x 2 to x, correct?
Oh, yeah, 2.
Right? So then you plug it in x, you're gonna have 2x squared. Oh, 2 and 2 cancel out. So just x squared. X squared minus what? Minus 4, correct? And then now you're taking the derivative. What is it equal to? 2x, right? Is it so short? You take one way. Oh, by FTC, you got 2x already. Okay? If you know the long way, you don't do the FTC. Oh, you're gonna take the integral. After you got the integral, you're gonna take the derivative. That's the long way. So that's the application of FTC. Yeah. Huh? The 4? What is the derivative of 4? 0. Don't confuse about derivative and integral. Maybe you talk about integral, right? Yeah? So that's the application of FTC. Let's do example 2.
Holy shit. This looks hard.
Yeah, this is the long way. This is the long way. Okay? Long way. Oh, I did write it. Okay, how do you do this one?
So we should still keep the word.
Now, what is the difference? What is the difference?
We have a 1. We have a 1 over square root.
We have a fraction. Square root.
Okay, first, the function is more complicated. The whole thing here is a function ft. Yeah. Do we need to worry about negative 2? And do you know why we don't need to worry about, we don't need to worry when it's the number?
It's just a constant.
Yeah, why don't need to worry about constant? You know why? Why the FTC?
Doesn't have an x.
Why the FTC? They just say that this actually equal to just the upper limit. You don't need to worry. You don't need to worry about a constant. Why?
It'll get canceled out when you do derivative, no?
Oh, exactly. Yeah. Look at what happened when we do what happened to the constant. Oh, 2, right? And when I plug it in 2, I got 4. It's still a constant, correct? And then when you're taking the derivative of the constant, it's going to be gone. So when you see the constant, when you see the number, just ignore it. It doesn't do anything. It doesn't matter, okay? But if you see this one to be a function, oh, you need to take care of it because it's not going to be gone, okay? In the picture, the what does it mean is this? If you start from a number, let's say this is a number negative 2, right? If you start from negative 2, this number negative 2 is going to be fixed. And when you take the derivative, you check in how the function is going to be changing. So x squared, how do they changing? They're changing like this, something like parabola, right? This one going to be no changing because that's a number, a constant, and that's why they're gone. But if you have some function, that means they're also changing it, then you need to take care of it. I'm going to show you a sample, don't worry. But long story short, when you see the number, you don't need to worry about it. You need to take care of the top, the upper limit. So by FTC, what is this equal to? Okay, by FTC, part 1, this is going to be equal to what? 1 over square root of huh? Someone say it. I just heard someone say that. Who said that? X? X4. Why X4? Yeah, this one is only the X. So when you plug it in here, it's still X, right? But this one is X squared. So when you plug into the T, X squared again, it's going to be X4. Good job. So X4 plus what? Plus 3x squared. Very good. Okay, this is by FTC,
Mm.
right?
Not that bad.
Are we done though? Is it finished though? Why is not finished? There's something we didn't take care of. There's something we're still missing. What is that?
The square root?
The chain rule. Very good. Very good. Why chain rule? Remember, this at FTC they only talking about the x, right? Like for example, the sine x, the derivative of sine x is cosine x, right? But the derivative of sine of 2x, the derivative is cosine of 2x, but you need to times 2. So when they have the x, that's just straightforward. But when you see something different from x, no matter how simple it is, it's 2x, but it's still different. Then you need to do the chain rule. So how do you chain rule here? Times what? 3. Oh, now the question is what chain rule you're gonna apply? You apply the chain rule to here? Yeah?
Shouldn't we do the top one? No, x squared.
It's
Just times.
Just the x squared, yeah. This is only a chain rule for this. Yeah? The FTC they're saying this is x. But now this is not x anymore. So that's where you're gonna apply the chain rule. This is just a function. You don't need to worry about it. Concept, the function can be more complicated. It can be crazy. It doesn't matter. It's just a function. This is the one that you need to use chain rule. Because what you know is only when they have x only. That's what you know. But now they give you x squared. That means you need to do chain rule. So, or you can think like this. dt, correct? What is a t? T is now, t is, but t now is the x squared, right? You just replace the t with x squared. Do you agree?
Oh, yeah.
So dt, you can think like this. dt is d of x squared, right? dt is now become d of x squared. What is the derivative of x squared? Is 2x. So now this become 1 over x4 plus 3x squared times 2x. You just use the chain rule anyway. You just use the chain rule. So here's the chain rule. So let me use this one now. So chain rule here. And then here we replace t. T equal to x squared. Okay? That's what happened. Can we simplify this? Is there any way we can simplify this? How do we simplify this? Is there anything we can do to simplify this one? Huh? X squared? You factor out x squared. What do you have left? X squared plus 3. Then what next? We simplify. Okay, we simplify. You have to simplify it. What next? You're gonna take the x out because x square root. What is the square root of x squared? No.
1 over 2. 1 over
Even worse.
over x squared. Wait, what? Square?
What is the square root of x squared? No.
What is it? Is it not x?
X.
Yes, square root of x squared. Huh?
Why is it not X?
It's not x.
Why?
Then what is
Plus
that?
minus X?
Then what is that? Then you're getting closer. Yes. What is that then? Huh? Absolute value of x. Be careful. A lot of students got a point off for this. On the multiple choice, imagine they give you something like this and they give something not that, and then you just see the x first. They put the x first on the answer A. You just see the A and then you mark the A. It's wrong. Often they put this one like A B C D. They put it one on the D, and you just skim over. You see the A. Oh, that's the answer. And you put the A. Okay. Read the question. Read the answer. A B C D. Read all of them. Okay. That's your answer. So far so good? Very good. I think we go now to the momentum of the like we catching up and now we on a good progress.
I would just need to study this. Oh Lord, we have an equation. Oh no, we have two.
It's getting harder, huh?
Oh fuck.
Now, what happened to negative 2? Do we need to care about it?
Yes.
No.
Now we do.
I mean, yeah, negative 2 here, do we need to care about it?
Oh, no.
No, right? Because when you take the derivative of constant, they're going to be gone. Now, do we need to care about the bottom?
Yeah.
Yes, because it's now in a function. Okay? What we're going to do?
I don't know. That's
We pray.
And then you
It was
minus.
there before you though.
Right?
Huh?
Then you just minus.
You just minus that. That's it. That's the only thing you need to do. Just minus it.
It's just more work, mister.
It's,
It's a long way essentially.
no, it's not really the wrong way. It's just you're still using
We're still switching it out. We still have to
this.
subtract it.
This is still the FTC but part 2. Like the end, the ending point minus the starting point. That's it.
Function.
Okay. So by FTC.
Or maybe it is. I just know you subtract.
Why is this then?
Subtract.
God knows. No. Ellen.
Yeah, very good.
No, because you still have to fill in.
Just do the same thing we just did, but now we're gonna do 2 of them, and then you subtract. Ugh. See my sore throats? Don't let me talk too much.
Maybe.
1 over 3.
All right, who wants to do this? I'm gonna start calling the go call. Okay? I'm gonna start and call one by one. All right, Isabel, let's go. Yeah?
Why? But it's says to just.
I'm gonna call one by one.
Yeah.
So would it be something like that? Multiply? You multiply with 3 and 3?
Maybe you can just do one of them. The top.
Wait, you said not the one way, but can I do it the one way?
No.
No.
Just apply. It's faster. Just apply the FTC.
I don't even know what you wrote, big dog.
That's right. Very good. One more close parenthesis. One more. If you have 2. Yeah. Okay. And then d of over dx. But now because now we come. Yeah. Yeah. That's it.
Oh, that's it?
That's it.
Oh!
That's the FTC. See? Well, yeah. You need to simplify. Maybe simplify this and then
Yeah, okay.
so equal to.
Oh, it's over.
Yeah, using FTC very applicable. It's short way. You don't need to do the long way.
Oh yeah.
And then what is the derivative of that? 3 times 4,
Oh,
right?
okay, oh, totally.
Yeah. Right, that's it.
Yeah, that's it?
That's it. Right? Good job, good job. I'm gonna use some point. I want you to do then the second one. What do you want? I'm gonna call.
X squared though. Oh no, that's just the top one. Oh.
I want you to do the second one.
Wait, mister, so then the second one, you
Yeah.
just.
Okay, Brad, let's go.
You just. No.
Yeah, let's go.
Oh.
You can do it, you can do it.
I put myself in a hole. Did you just do the same thing?
Do the same thing. So now you're gonna write minus. That's just the top minus the bottom, right? So minus, and now you're gonna do the same thing.
So
then Look at this one into the T. Yeah. Uh-huh.
X. Wait, is it to? Oh no, it's X squared. X squared. And then d of x. No. Do I keep the d of x here? Oh no, because it's derivative. So then that's chain rule.
So basically, you plug it in. You plug it in the t by x squared. Okay.
Is it like that?
You're missing the 3.
Oh yeah. 3x squared.
Yeah. Yeah, that's it. That's it. Good job. Yeah.
So now.
So minus. So here combine 2 steps in 1. So this is the d of x squared over the x, right? So basically you replace the x, whatever you have here, into the t. And dt, that means also d of those number, okay? So now you're gonna have 2x. Oh, I already wrote it already. So 2x, I'm gonna bring 2x, x squared, derivative of x squared 2x, and bring it to the front. 2x ln 3x squared. That's your answer. Okay? See? Only 2 lines. Only 2 lines. Yeah?
Do you need to do the d over whatever? You have to show it, or can you skip it?
This one?
Yeah.
Oh, if you know the derivative of this, then you can just get directly. You don't need to, yeah. Minus 2x ln 3x squared. Question? Ask me. Question. Yeah? Okay. Any questions so far? Yeah.
Why did the 2x, like the final part, go in the front of the ln 3x but not the 12x?
Like over here?
Yeah, like why?
Yeah, it's just the way of you writing it. Usually you should put on the front. Yeah, usually you should put on the front. Because of the y negative thing, this is inside the ln. So usually you're gonna put like this. 12x cubed. Yeah.
Okay, I got it.
Yeah?
Can we do another one?
I like
Another one?
Yeah.
No.
Oh.
Yeah, let's see. Let's have another sample. Anyway, this is the final area first. 0 to 2 is the area of triangle. So 1/2 makes some height. And then same thing, you double the triangle here. You get 0 to 4. 0 to 6, you're gonna add another triangle. And then 6 to 8 is a trapezoid. So you're gonna add the trapezoid, then you get 1.5. Question is, where is chi increasing? Now,
2 to 6.
2 to 6?
Yes.
It's not to
No.
6, Mr.
No.
No, look, Kayla,
6 to 7?
look, Kayla already said it.
4 to 8.
It's 4 to 8.
How?
But why 4 to 8?
Because that's positive.
Chi is the integral of f. Well, in other words, f is the derivative of g, right? F is the derivative of g. That means g is the position. So when you take the derivative, you get the f. So this graph right here actually showing you the velocity,
Oh.
right? The rate of change. So where g is increasing, whenever the function of the slope is positive, right? The slope is positive, the whole thing here.
If it was the other thing, it would have been 2 to 6.
Yeah, right. When they're increasing. If this is actually the function of g, then it's going to be 2 to 6. They're increasing. Okay? But this is not. This is the function of the derivative of g. That means the function of the slope. So then it's going to be from 4 to 8. Alright, good. Let's try another one. Let's try
Mr.
this
These are
color.
BC, right?
We're gonna go one by one.
Mr. Are these BC?
Yeah, this is kind of going into BC. 11. Oh, we only have 4 minutes? Okay. Where are the local extreme?
Oh, I know this.
You're tracking the velocity.
It's
Where? What?
2.
Where?
And 6 and 7. 6, 7, 6, 7.
What?
Is that wrong?
What was the question?
Oh wait, no, it is.
What are?
What's the question?
Where is the local extreme?
4.
Remember, this is the function of the derivative.
Yeah.
X equal to 4. Because that is where they're changing from the negative to
Positive.
when do you see the local maximum? When they change from negative to positive, you have the local minimum, right? When they're changing from the positive to negative, you have maximum. So here they're changing from the negative to positive. That means this one is the minimum right there. Okay. So at x equal to 4 is the local minimum. Yeah, because they change it from negative to positive, right? They can change it from the negative to positive. Oh, look at the face.
Oh, Mr. Slow.
Whoa.
I was looking for the little bit.
Yeah.
You remember Mr. Slow? Yes, he's a face. Mr. Slow. Mr. Slow.
Maybe next time. Okay, we continue next. Next is you're gonna sketch the graph
The position.
You got that, bro.
of gx.
I don't like that.
Rough graph. Because you maybe you're not gonna get exactly the same, but the rough graph. Okay, then you can start backing up.
A position.
All right, that's it.